This video is intended to give you a good background for doing calculations that involve things where you're calculating or changing grams into moles, or you're changing particles into moles. And there's only 2 ball games in town, and I'm going to show you both of them. And by the time we're done, hoping that this is going to make sense to everyone. So let's start out with the first ball game. Okay, in this ball game, we play, I'm given particles, and I'm trying to find moles. Whatever will I do? Well, this ball game is dependent upon this guy. Are you ready? Yeah, the big one. Okay, so when we're playing with this one, the game is we're starting with particles and we're trying to convert to moles. So here we have the particles, whatever number of particles we're given. We're going to change the particles into moles because we know that the Avogadro number, which is what this guy is going to tell us how many particles are in 1 mole of any substance, whether it's atoms, molecules, or formula units. And we're going to do some examples of this right out of your homework from the weekend and hopefully set these concepts for you really, really well today. So, particles is going to be the first fraction in the calculation, and that fraction is going to allow us to change into moles because particles that we're given will be canceled by particles of the Avogadro number, or that are the Avogadro number, and then that will change us into moles. So the equality is 6.02 times 10 to the 23rd particles are equal to 1 mole. And this could be atoms, molecules, or formula units. Formula units, if we're talking about something like a situation where you have an ionic compound that is in a crystal structure, but that crystal structure is not a big molecule. It's just a whole bunch of formula units held together by very strong magnetic forces because we have very polar bonds going on, like in sodium chloride, normal table salt. Okay, so here we are. This is the first ball game. Now, here is really the other side of the same ball game. Oh, wait a minute, Mr. Wigger. I see moles. I see atoms, molecules, formula units. And I see atoms, molecules, formula units in both of these. Oh, is there a difference? What's different in these 2 screens? Particles and moles. Okay, and the particles that are here are meant to tell you that we're starting with particles. Here, we're going to start with moles. But we still have to use this number. Okay? That number's the same for every single atom, for every single particle, molecules or formula units, you name it. 6.02 times 10 to the 23rd is the number. So, let's see what happens when we look at how we do the calculations. Here they are. Ta-da! Wait a minute, Mr. Wigger. These are the same. Are they? Ooh, what's the difference? That first fraction in the calculation, it's different, isn't it? Here we start with particles, just like I was just explaining, particles. And then here we're starting with moles. And how is this fraction different? It's still the number of particles that equal a mole. What's the difference between this fraction and this? Okay, a lot of students like to say, and I think it's probably a good way to think of it, that you're just flipping the fractions, right? Flipping back and forth, depending on what you're starting with. You see, up here, I can take particles down and start with moles. If I do that, what do I have to do with the second fraction? Flip it. Now it works, right? Now I'm starting with particles, and I can get, I'm starting with moles, and I can get particles. Okay, so I'm going to put this back the way it was, and then of course I have to change it back here. And just like I did up above, I can start with particles. I like doing this because you're seeing that I'm flipping fractions in both cases. Because you can't cancel particles, which is what I have here now, you can't cancel that with anything but particles, which is what the Avo number is. And so moles is what I'm converting to. But really in this second one, I was trying to demonstrate more that moles are, when moles are your starting, you can't have moles times moles because that's moles squared. Are you all aware of that? That's moles squared? Yeah. So moles squared doesn't do you any good. But here we get rid of moles because these guys are going to cancel. And that leaves you with particles. In this one up here, particles are going to cancel, and that leaves you with moles for your answer. How am I doing? Is this making sense? I hope so. And so let's go down and see if I can get this to come down a little bit. No, it was the whole thing. I'm going to stop the recording just a minute. Okay, ball game 2. Here it is. Grams. Grams that equal 1 mole. What? What do you think the ball game is now? It's not 6.02 times 10 to the 23rd anymore. Where do I have to go to get my numbers? Oh, you stole my thunder. By golly, that's what we see on the periodic table, that kind of thing, yes? Okay. Is it the same for every number, for every element? Oh, no, every element is different, isn't it? There are no two elements that are the same. So, what does the converting? That guy. The guy at the bottom, that's the number of grams that equals 1 mole. And I'm going to end this video to keep it short. And what we're going to do next, and if you want to follow us on YouTube, this next video will follow this one. I'm not sure which one will come first. I'll try to make them follow, but whether I do or not, they'll be together so far as the date sequence order is concerned. So thank you for watching. I hope this gives you a good background that you'll be able to apply to the next video.